In the previous lesson, we talked about the history of reinforcement learning before neural networks were introduced. Now, let's see how neural networks changed the game. We're going to go over two major reinforcement learning neural network algorithms, and then finish off with a discussion on how the engineering behind bringing these algorithms to life can enhance our agents. There is this renaissance happening today with neural network applications of reinforcement learning, but the practice has been around since the early 90s. There's actually an X-Files episode called Ghost in the Machine with what's called an adaptive network, or learning machine. TD-Gammon is famous for not only being one of the first hugely successful reinforcement learning algorithms to use neural nets, but also because it's one of the first RL algorithms to beat humans at a strategically complex game. I'm going to take a walk down memory lane, because I was actually a kid at the time when all of this was happening. Both of my parents are gamers. They've played Dr. Mario every night against each other for the past decade and a half. My dad in particular is a very big fan of chess. To this day, I can't beat him. That's why I make robots to beat him for me. So in 1994, when IBM's Deep Blue defeated the chess world champion, I remember my dad got very excited about the future of computers and artificial intelligence. Chess was, and still is, considered one of the most intellectual games. So the hot topic became, where do computers go from here? And the artificial intelligence community shifted their attention to backgammon. I actually remember my dad teaching me backgammon with all the hype surrounding it. Why all the hype? The goal of backgammon is to move all of your checkers into their home position. This is done by taking turns rolling 2 dice, and by assigning each dice to a checker and moving it the same number of spaces rolled. Like chess, there are many possible positions that can be played, but unlike chess, there is an element of chance. It turns out that even before IBM's chess victory, another IBM employee, Gerald Tesaro, experimented on combining temporal difference learning with neural nets in order to master the game of backgammon. So why the need for neural nets? Why not use our good old friend the Q table? There are a few downsides to the table format. The first is that the space is needed. In our frozen lake, we only had 16 states and 4 actions, so that's 64 cells. At backgammon, each player has 16 checkers, and there are 24 possible columns that they can sit in. With each combination of positioning, the number of states is in the quintillions. The other issue, although this doesn't apply to backgammon, is that each state must be assigned a discrete number. If we have a problem with continuous values, like x and y position coordinates, we would need to convert it into an integer value. First, it would be difficult to figure out what value should be assigned, and we might lose valuable information in the process. Instead of trying to account for each possible board position, Tesaro fed in state information in a neural network, which was designed to approximate TD-Lambda. The agent would play by rolling the dice, and then calculating each possible board position from those dice rolls. It would feed those positions into the network and select the action corresponding to the highest possible state. While TD-Gammon was ranked just below human backgammon grandmasters, it was still considered a huge success in the AI and backgammon communities. Its play was strong enough that new strategies were developed based on the AI's insights. The reason why it lagged behind human players was due to its endgame play. Data for these types of situations were sparse, and so it was weak at predicting the value of endgame states. Interestingly, TD-Gammon's strengths and weaknesses are the reverse of Deep Blue. The chess algorithm works by brute force calculating many moves in advance, so its endgame is very strong and is weaker during the earlier turns of gameplay.